All right, now we're going to look at number 10 on the back of the review sheet. So it says, while on the moon, the Apollo astronauts enjoyed the effects of gravity much smaller than on the Earth. If Neil Armstrong jumped up on the moon with an initial speed of 151 meters per second, so I'm going to write my given. So VI is equal to 1.51 meters per second to a height of, so I know this height is 0.70 meters. What amount of gravitational acceleration did he experience? So I'm looking actually for G. All right, so that answer should be meters per second squared on this worksheet. I forgot the squared. Okay. Now, before I do this problem, what I would do is I would draw a picture, because I'm not sure what height this really is. So if I draw a picture, it helps me to visualize. So here is Neil Armstrong. He's starting off on the surface of the moon. Okay. And what he's doing is he's jumping up to a certain height. Okay. So when he leaves the ground, his initial velocity was 1.51. So this is the maximum height. At the maximum height, what's his velocity? 0. You see how the picture helps out? Now also, they said that this height, so you can start off here on the ground, the height is 0 here, and then here the height would be 0.7. Okay? So this problem is conservation of energy. The total energy before is equal to the total energy after. So the total energy before is a sum of the potential and kinetic. So KEI plus PEI is equal to KEF plus PEF. Now, before I start plugging in like what's KE and P and all that other stuff, let's think about what's going on. So down here in the beginning, he's on the ground. Does he have kinetic energy? He does, because they told you the velocity, right? So the kinetic energy is 1/2 mVI squared, because this is his initial velocity, VI. Does everyone see that?
When he's on the ground, he has kinetic energy.
This is just when he's jumping. Okay, so that's that infinitesimal second when he just lifts off the ground. It's like when something is dropped, you know how right before it hits the ground, that's the maximum velocity? Remember when we did something and it dropped like this, and right before it hit the ground, we said, what's VF, and that was the maximum velocity? So this is also the maximum. So this velocity is a maximum because when he jumps off the ground, as he goes up, the gravity of the moon is pulling him down, and this velocity, because gravity is pulling down on the moon, this velocity is going to decrease till he gets to his maximum height, where the velocity is 0, right? Think about the problems we did in Chapter 2. I could actually solve this like I did in Chapter 2 if I took a ball and I threw it in the air and they said the velocity when the ball left your hand. It's the same type of problem. I can solve it the same way, but when if we have a problem like this on the test, I'm going to specifically say use energy considerations only. I'm not going to let you use the equations from Chapter 2. Okay? The potential energy here is 0. So this is 0. At the top, the velocity is 0. So what's the kinetic energy at the top? 0. And the potential energy at the top is going to be mgHF. So this is HF, because that, according to my picture. So now, what do I want to solve for? I actually want to solve for G. I want to solve for the acceleration due to gravity on the moon. Now, most of us know that gravity on the moon is 1/6. That's what it is on Earth. So when we get our answer, it should be about 1/6 of 9.8. So now what I'm going to do is I can factor out the m, because I don't know his mass, but you see how I have an m on both sides? So I'm going to have 1/2 VI squared is equal to GHF. Now, since I'm solving for G, I want to leave it in the numerator on one side of the equal sign all by itself without any negatives or anything. So now I'm going to divide both sides by HF. So 1/2 VI squared divided by HF is equal to G. So it's 1/2 VI, which is 1.51 squared over 0.7. So now when I take out my calculator, 1.51 squared times 0.5 divided by 0.7, 1.63. And that is 1/6 of 9.8. So that's the acceleration due to gravity on the moon. Okay?